Report on the development of technological innovation and digitalization of the national transportation sector's energy transition. Introduction. Indonesia's transportation sector is undergoing a major transformation, driven by the adoption of green technology and the digitalization of monitoring systems. This strategic step was taken by the government. Optimizing clean technology and public sector energy transition. The Indonesian government has officially adopted two cutting-edge technological approaches to reduce carbon emissions in the mass transportation sector. Hydrogen conversion technology in buses. Through the collaboration of the Directorate General of New and Renewable Energy and Energy Conservation, EBTKE, of the Ministry of Energy and Mineral Resources, and Perum Damri, a pilot project for a hydrogen diesel dual fuel H2DDF mixed fuel conversion bus is prepared to be launched at the 2026 Global Hydrogen Ecosystem Summit, GHES. This technology is an efficient transition solution because operators do not need to replace the entire fleet. The government is committed to overseeing safety aspects through technical studies, detailed engineering design, DED, and homologation to ensure safety on public roads, towards the target of commercializing hydrogen in the transportation sector by 2030. Technology. To address the high cost of electrification of conventional rail lines in Indonesia, which currently only reaches 10%, Part KAI Persero, in collaboration with Point Inca, will operate a battery electric multiple unit, BEMU, starting in the second quarter of 2027 on the 42-kilometer Padalarang-Cicalengka commuter line. With flexible battery capacity, lightweight, and fast charging capability, 10 to 15 minutes, this technology enables the operation of electric trains at speeds of up to 120 kilometers per hour independently, without the need for overhead power cables. Hydrogen diesel conversion bus trial. Technology uses hydrogen diesel dual fuel H2DDF technology, a transitional system that mixes hydrogen with diesel without requiring a complete replacement of fleet engines. Objective: accelerate the decarbonization of mass transportation and build a national hydrogen ecosystem in line with the 2060 Net Zero Emissions (NZE) target. Target and support. The Ministry of Energy and Mineral Resources fully supports the technical study, detailed engineering design, and homologation process to ensure roadworthiness. This bus is planned to be launched at the 2026 Global Hydrogen Ecosystem Summit, GHES, with a target for commercialization in the bus and truck sectors starting in 2030. Of the impact statement from Mr. I.R. Senda Hormuzan Kanam, MSc, Director of New Energy, Directorate General of New, Renewable Energy and Energy Conservation, Ministry of Energy and Mineral Resources. Impact of hydrogen technology. Hydrogen is projected as a clean molecule that paves the way for cross-sector decarbonization, not just energy diversification. Impact of the H2DDF solution. It is a pragmatic and efficient transition solution because it can gradually reduce carbon emissions without burdening operators with the cost of replacing the entire fleet, while maintaining vehicle operational reliability. Of battery-based electric trains, BEMU, in Bandung. Technology. Battery Electric Multiple Unit, BEMU, an electric train that does not require overhead power lines. The battery is sophisticated, lightweight, and only takes 10 to 15 minutes to fully charge. Trial route. The 42-kilometer Padalarang-Cicalengka commuter corridor, passing Cimahi, Bandung, Kiara Kendong, Gede Bage, Ranca Ekek, etc. Speeds can reach 120 kilometers per hour, with a headway of 15 to 30 minutes. Season and schedule. The level of rail electrification in Indonesia is still very low, only 10%, and expensive. Battery technology offers a quick solution. Part KAI is collaborating with Point Inca and is targeting the procurement process to begin in September 2026, with delivery of the first train set in the second quarter of 2027. Highlights of the impact statement from Mr. E. Gede Dharmayusa, Director of Portfolio Management and Information Technology, Part KAI, BEMU Cost Efficiency Impact. The use of BEMU reduces the waiting time for railway electrification. KAI can immediately provide electric commuter services without the need for expensive investments in the construction of an overhead power line network. Scalability impact. If the pilot project in Greater Bandung is successful, this battery technology will be widely adopted in other cities in Indonesia that do not yet have an electric rail network. Modernizing logistics supervision through digitalization. Sumba apps. In the freight transportation sector, the Ministry of Transportation launched the Sumba, Surat Muatan Barang application, as an integrated digital e-manifest system. This innovation requires logistics business actors to input data electronically through a 5-step digital form, covering vehicle, driver, owner/recipient, commodity type, and route. This step is designed to strengthen freight transportation supervision to ensure the success of the Zero Over-Dimension Overloading program by 2027. The Sumba dashboard will be integrated with other ministries to present national logistics movement data transparently. Launch of the Sumba application by the Ministry of Transportation. Function. Sumba, Surat Muatan Barang, is a digital e-manifest application for recording and monitoring cargo loads in real time and in an integrated manner. Purpose. Support the 2027 Zero ODOL, Over-Dimension Overloading program, improve road safety, reduce infrastructure damage, and increase transparency of national logistics data. How it works. The system integrates vehicle data, license plate number, inspection number, driver data, driver's license, and data on the carrier, owner, and recipient, as well as details on the cargo and route. Business operators are required to register an account through the Ministry of Transportation's official website and complete a 5-step form to issue a digital cargo manifest. Highlights of the impact statement from Mr. Honda Lesmana, ATD, MT, Head of the Subdirectorate of Freight Transportation, Directorate General of Land Transportation, Ministry of Transportation. Manifest impact of digitalization. The electronic presence of Sumba significantly increases the transparency of cargo data and facilitates regulators in monitoring business compliance. Macro impact. Directly impacts road safety, reduces state losses due to road infrastructure damage, and creates more effective, orderly, and sustainable enforcement of freight transportation regulations. Conclusion. The adoption of green technology and digital monitoring systems is a crucial strategy in the transformation of the national transportation sector. The integration of hydrogen bus, H2DDF, and battery train, BEMU technology has been demonstrated to accelerate the achievement of the 2060 net zero emissions target by significantly reducing greenhouse gas emissions. This innovation has been demonstrated to engender considerable state budget efficiency, attributable to the diminished costs associated with overhead power cable infrastructure. Financial advantage is further bolstered by the introduction of the Sumba system, which proactively mitigates the costs associated with road maintenance due to over-dimension overload vehicles. This combination of technologies and strict homologation has been demonstrated to engender an environmentally friendly and budget-friendly mobility ecosystem, whilst also ensuring the highest safety standards for the public on the highway.